This presentation deals with some of the outlying issues in capital budgeting. They include projects with unequal lives, which is a case where if we have two competing projects with two different maturities, which one should be selected. The second one is economic life analysis, which is a way of seeking to determine the optimal life of a project. And finally, investment timing option, which is a case where a firm may have the option of embarking on a project, say either right now or wait a couple of years before getting on board. And the question is, which beginning time, which startup time would result in a greater project value. All right, so here's a quick example for projects with unequal life. So here we have two projects, A and B, and we can see that A is a 5-year project, B is a 3-year project. Based on the cost of capital of 10%, we find that the NPV for A is greater than that of B. Now keep in mind that part of the reason why this NPV may be higher than project B's NPV may be because of the fact that A is a longer project. And so comparing two projects with unequal lives directly may lead to making the wrong capital budgeting decision because the two projects are not comparable. They have different lives. We can't compare things that are not similar. So what we want to do is to come up with a technique that can adjust for the unequal lives. There's a couple of methods discussed in the literature as well as in finance textbooks, but the one that I show here is called the equivalent annual annuity approach. Now, what this approach requires is for us to identify the NPVs we calculated earlier. I go back here, these two values right here. Right, we identify them as the present value of a project that can be operated for, in the case of project A, 5 years, and in the case of project B, 3 years, because these are the lives of the two respective projects. Now then, given the cost of capital, we ask the question, how much cash flows can be generated from project A each year for 5 years? And ditto for project B. And we find here that if we look at this NPV here for A as present value, and 5 is in, and 10 is the rate of return or the cost of capital, and then compute the annuity cash flow payment, we find that that for B is greater. Because what this is saying is that while for A, each year within the next 5 years, we can expect to earn $6,914 and change, that for B, each year within the next 3 years of operation, we can expect to earn even a much higher amount of $9,291. So now you may ask, why make this kind of assumption? Well, it is based on the assumption actually that each of these two projects can be repeated after each segment of expiration period. In other words, for A, after 5 years, we can reinvest in the project. In other words, say this is like a manufacturing machine, we can keep investing in this particular brand of manufacturing machine whose longevity is only for 5 years. So if we repeat this investment behavior every 5 years indefinitely, then we can ask the question, how much money can we make each year during each 5-year period? And the same question would have to be asked for B. If we can repeat project B, in other words, purchase the same 3-year machine every 3 years, then the question becomes, how much money can we get out of it each year during each 3-year period? And the answer here is B is better. We stand to get more bang for our buck by choosing B over A. So it's as simple as that. Now then, the next issue here is economic life analysis. Some call it abandonment value analysis, which is a way of trying to determine the optimal life of an investment. Say, for example, we have this 5-year investment here, promising to return $6,250 each year for the next 5 years. The cost today, though, to invest in it is $22,500. So now we have a choice, actually a bunch of choices. We can hang on to this project for a year, in which case, having spent $22,500 to invest in it, we would only be making $6,250 in the first year and then get rid of it for a projected amount of $17,500. So that the cumulative cash inflow, if this project is held for only 1 year, as I show here, would be $23,750, which is the sum of this cash inflow and this salvage value. If on the other hand we hang on to the project for 2 years, then having spent this money right now to invest in it and making $6,250 in the first year, as I show here, we stand to make a total of $20,250, which is the sum of the second $6,250 and the projected market value, also called salvage value. So in the same way we determine what the set of cash flows would be if held for 3 years, 4 years, and 5 years, and then calculate the NPV under each of these scenarios. And here in this example we find that the NPV is highest if the project is held for 3 years, and therefore to invest in this project the optimal period to hold on to it would be 3 years. Now bear in mind that this type of result is as good as the estimates that you're working with are. And then finally is investment timing option. Now here's what I'm going to do to give you a quick understanding of how this works. Say we have a project, a $10 million project. This project is a 12-year project, as I show here. Each year it stands to make $1.8 million. So this is going to be an annuity for the next 10 years. So at 10% we find the NPV to be $2.26 million. So based on this result, we should accept this project. Again, this amount here is the net present value of our $10 million project, promising to return $1.8 million per year for 12 years, and the cost of capital is 10%. This is the NPV. It's positive, and so we accept. Now though, there is an issue that can make this story more interesting, and that is we can choose to delay starting this project for a couple of years. But if we delay it for a couple of years, one of two things might emerge. One is that the tax liability associated with this project, as you may get to understand from reading the background story, would rise. If it rises, then the expected cash inflows, for whatever the reasons are, quite well understood, would fall to 1.5 million. So that now this 12-year project costing 10 million, if we delay it for 2 years, our projected cash inflows would now be only 1.5 million. And so the NPV will shrink to only 220,538. And seeing that this project won't get started until 2 years from now, it means that the value today, which would be finding the present value of this 220,538 over 2 years, would be only $182,263. Now, you might say, what's this about? Well, keep in mind, if you suspend embarking on this project for 2 years, it means that the NPV you calculate would be the NPV that is situated 2 years from today. So you have to bring it to today's dollars by discounting it over 2 years, and that comes down to $182,263. That's what's up right there. Now then, the other is the tax may not be imposed. Alright, advancing the slide, if tax is not imposed, we find that our projected cash inflows would actually rise to $3 million, which would cause the NPV to be 10.44 million, a huge difference. And in today's dollars, because you got to bring it back again 2 years, would be 8.6 million. So to spice up this story here, we are assuming, if I go forward some, that there's a 30% chance that the tax will be imposed, and therefore the odds are 7 out of 10 that the tax will not be imposed. So the weighted average net present value would become $6 million and change, which is zero point 0.3 times the NPV if tax is imposed plus zero point 0.7 times the NPV if tax is not imposed. So with that, this is the weighted average NPV. So final analysis, what should we do? Start on the project right away, and as we showed earlier, the NPV would be 2.26 million, or delay the project for a couple of years, in which case the weighted average NPV would be 6 million. Well, as you can see, waiting for 2 years would on average result in a higher NPV. Now, you would agree that there are a couple of issues here. One is that this is based on a probability, and if your probability is way off, then something bad you'd be making very bad decisions 2 years from now. The other is, if one of these probabilities leads to the NPV turning out to be negative, then actually this option will cease to exist. So if this NPV with tax imposed were to be negative, that means if you waited 2 years and tax is imposed, you will definitely not even get on board as far as this project is concerned, since it'll result to a loss in value. Therefore, in investment timing, when one of the outcomes has a negative NPV, you should convert this to 0. You wouldn't have to go 0.3 times the negative value, since in reality you wouldn't be starting on the project anyways, and that'll cause this argument here to be 0, so that the effective outcome here would be 0.7 times this value right here. So just keep that in mind, because it has to reflect reality, which is when NPV is negative, you do not embark on a project.